One of the most profound similarities between Earth and Mars, one which makes it a popular target for research and exploration, is the presence of water ice on its surface, mainly in the form of its polar ice caps. But perhaps even more interesting is the presence of glaciers beneath the surface, which is something scientists have speculated about long before their presence was confirmed. These caches of subsurface water could tell us a great deal about Martian history, and could even be an invaluable resource if humans ever choose to make Mars their home someday. According to a recent study by a pair of scientists from the universities of Texas at Austin and Arizona, there are also layers of ice beneath the northern polar ice cap that could be the largest reservoir of water on the planet. The findings were the subject of a study that was recently published in Geophysical Research Letters. The study was led by Stefano Nerozzi, a graduate student from the University of Texas at Austin's Institute of Geophysics (UTIG), and was assisted by Professor Jack Holt of the University of Arizona's Lunar and Planetary Laboratory (LPL). A view of Mars showing the planet's northern polar ice cap. Credit, ISRO, ISSDC, Emily Lakdawala for the sake of their study, Nerozzi and Professor Holt relied on data gathered by the Shallow Radar instrument aboard the Mars Reconnaissance Orbiters (MRO), which is capable of penetrating up to 2.4 kilometers (1.5 miles) beneath the surface using radar waves. What they reported was the discovery of several layers of sand and ice roughly 1.6 kilometers (1 mile) beneath Mars' North Pole. These layers were found to be 90% water in some places, and are believed to be the remnants of ancient polar ice sheets. If melted, the researchers indicate that they would create a global ocean with a depth of at least 1.5 meters (5 feet). As Nerozzi explained in a UT News press release, this find was quite surprising. "We didn't expect to find this much water ice here," he said. That likely makes it the third largest water reservoir on Mars after the polar ice caps. The findings were corroborated by a separate study, on which Nerozzi was a co-author, that was led by researchers at Johns Hopkins University and also appeared in the Geophysical Research Letters. For this study, the team relied on gravity data to place constraints on the density of the area beneath the polar ice cap. From the low-density readings they obtained, they estimated that the layer's ice and sand is more than 50% water overall. This discovery is a boon for scientists since these layers are essentially a record of past climate change, and analysis of them could reveal some very interesting things about the planet's history. In short, the geometry and composition of these layers could help scientists to determine if the Martian climate was ever favorable to life. A composite image showing alternating layers of ice and sand in an area where they are exposed on the surface of Mars, taken with the MRO's HiRISE camera. Credit, NASA, JPL, University of Arizona. As for how all that water got there, the authors theorize that they formed during past periods of warming and cooling on Mars. Scientists have known for some time glacial events take place on Mars that are driven by variations in the planet's orbit and tilt, much like Earth. Over periods of about 50,000 years, Mars tilts more towards the Sun before gradually returning to an upright position. When Mars sits more upright, the equatorial region warms while the northern polar region cools, causing the ice caps to advance. When the planet tilts towards the Sun, the polar region warms, causing the ice caps to melt. It is during these times that the remnants of the ice caps will become covered in sand, which has historically protected them from exposure to the Sun and dissipating into the atmosphere. Professor Holt, who was a research professor with the UTIG for 19 years before joining the University of Arizona in 2018, has been a co-investigator with the Sharad science team since the MRO arrived at Mars in 2006. Using data from this instrument, MRO was also able to confirm the presence of subsurface glaciers around Mars' mid-latitudes. As he stated, this recent find effectively doubles the amount of water ice known to exist on Mars. Surprisingly, the total volume of water locked up in these buried polar deposits is roughly the same as all the water ice known to exist in glaciers and buried ice layers at lower latitudes on Mars, and they are approximately the same age. Previously, scientists thought that the ancient ice caps were lost, but this study reveals that the northern ice sheet has survived under the planet's surface, arranged as alternate bands of ice and sand. This study not only contradicts that assumption but also provides new and important insights into the exchange of water ice between Mars poles and mid-latitudes. Another exciting possibility is the way that the study of these glaciers could help determine whether Mars was ever habitable. as Nerozzi explained. Understanding how much water was available globally versus in the poles is important if you're going to have liquid water on Mars. You can have all the right conditions for life, but if most of the water is locked up at the poles, then it becomes difficult to have sufficient amounts of liquid water near the equator. Thanks to a growing number of robotic missions that have been sent to Mars, what we know about the planet has grown by leaps and bounds. And with every new discovery, the need for further exploration becomes apparent. Someday soon, we may augment those efforts by sending human astronauts there, which may even pave the way for human settlement. And when those people arrive, the presence of subsurface glaciers will play a major role in their efforts.